to use the distributive property on these first few problems here at the top and simplify the problems. So if I was to distribute the 3 into this first set of parentheses, that means I'm multiplying every single term by the 3, right? So what is 3 times x squared?
3x squared.
Very good. And what is 3 times 2x?
6x squared. No, 6x.
Okay. And what is 3 times 6?
18.
Very good. Alright. Now let's look over here at number 2. I've got to distribute a -4. What's -4 times x squared?
-4x squared.
Very good. And what's -4 times -x?
4x.
Positive 4x, right? 2 negatives make a positive. Very good. And then -4 times 11. Very good. Alright. Now, some of these next ones have an x in what we're distributing. So remember, what do we do with our exponents when we multiply? Add them. Very good. So I've got 5x times -2x squared. So I multiply the numbers. What's 5 times -2? -10. I've got 1x out here and 2x or x squared on the inside. So it's going to give me x cubed. Very good. All right, then 5x times 8x. What's that going to be? Very good. And then 5x times 12. Very good. Okay. Let's look at number 4. We got 6x squared times -2x squared. What's that going to be? -12x to the what? 4. Very good. So we multiplied the 6 and the -2, which gave us -12. We've got an x squared here, an x squared here. We add the exponents. We get them. All right, then 6x squared times 5x. Yes.
That would be 30x.
Good.
But are we supposed to add those two since they're like terms?
What's like terms?
40x and 60x.
Where?
On the last problem.
Oh, sorry, this was supposed to be x squared. I just forgot to put squared. Thank you. All right, and then we would have 6x squared times -30, which would give us how much? -180. X what? Squared. Very good. All right. Okay, then we've got number 5 here. 9x cubed times x squared would give us 9x to the 5th. Good. And then 9x cubed times x would give us good. And then 9x cubed times 1 would just be good. All right, and then we got one more. So I got -5x to the 6 times 3x squared, which would give us -15x to the 8th. Very good. All right, and then -5x to the 6 times -12x would give us very good. Positive 60x to the 7th. And it is positive because both those numbers are negatives, right? Okay, and then -5x to the 6th times 30.
-150.
150 what?
X to the 6.
Good. All right. So now we've kind of refreshed ourselves on what the distributive property looks like. Now we're going to talk about how we do that in reverse, so undoing the distributive property. So in this next section, it says consider what your answers were for some of your previous problems, like number 1. So this was our answer, the 3x squared plus 6x plus 18. So it's written right here. They asked, what do you notice about the numbers 3, 6, and 18? Right. Right, they are all multiples of 3, or they are all divisible by 3. Very good. Alright, we could go through and divide every single one of these terms by 3. Alright, so this would become 1, 2, and 6, which were the numbers that we originally started with in the problem above before we distributed, right? Okay, and then they asked the same thing about number 2. Here's what we got for our answer on number 2. What do you guys notice about the numbers -4, 4, and -44?
They're all divisible by 4.
Right, all divisible by 4, or if we're looking at that first one, we might say even -4, right? So they are all divisible by 4 or -4. Right, if I was to go through and divide all of these terms by -4, we end up with 1, -1, and 11, which were the numbers that we had in that parenthesis before we ever distributed the -4, right? All right, and then they also ask about number 3. So what do you guys notice about these 3 terms? All divisible by 10. Anything else that we could take out of all of them? An x, right. All of these have at least one x in them. So we could divide all of these terms by -10x and end up with what we, well, this one we actually just distributed to 5. So end up with some simplified terms, right? So here we'd end up with 1x squared. Here we'd end up with 4x, -4x. And here we would end up with -6. All right. So here they were all divisible by -10x. Does anybody remember what we call this when we take out something that they all have in common? I'll give you a hint. It's our first step when we were factoring. Yes. Non-denominator.
Greatest common factor.
Factor. Right. Greatest common factor. It's the biggest thing that is a factor in all of our terms. So what we call this process factoring out the GCF. And our GCF just stands for greatest common factor. Okay, so now that we remember that this was supposed to be our first step in the factoring process, they ask us to do so on these 3 examples here at the bottom. So I'm looking for the greatest thing that they all have in common that will come out of all the terms. So on example 1, I'm looking for something that will go into -4x and 8. -4. We do want to take out a -4 because we always want our first number to end up positive. So I'm going to divide by -4 or take out a -4. If I divide -4x by -4, what's left? Just x. Very good. And if I divide 8 by -4, what are we left with? -2. And remember, this is how we write it when we take out our GCF. GCF in front, our leftovers are in the parentheses, all right? Okay, on example 2, what's something that we can take out of 2x cubed, negative 8x squared, and 22x? 2 what? 2x, right, because all of these have an x. So I'm going to put my GCF of 2x out in front. If we divide 2x cubed by 2x, what's left? Very good. All right, when we multiply, we add. When we divide, we subtract. So there was 3. We took 1 out, so just an x squared left. All right, what's negative 8x squared divided by 2x? Good. And what is 22x divided by 2x? Very good. Okay, and then we just have one last example to look at. So they want to know what would be the GCF between b squared, negative 3b, and 3. So can you guys think of anything we can take out of all of those terms? 1. And that would be it, right? If I take 1 out of all of those, is it going to change the problem at all? No. They all will still be the exact same term, right? If this happens, if there's not anything you can take out of all of the terms, then there is no GCF for this problem. All right?